Today's main topic, barrier-free showers, presented by Andy Acker, Director of Education and Training with Schluter Systems. He has 20 years of experience as a professional tile setter, including 12 as a California State C54 licensed contractor. Andrew has been with Schluter for 20 years and conducts educational workshops throughout North America. He currently sits on the board of directors of the Ceramic Tile Education Foundation, CES. Welcome, Andy. Look forward to your presentation.
Well, thank you, Jim. Thanks for the introduction there. Yeah, this is pretty exciting. We have just got back the submission of this particular presentation, so it does have some accreditation, and I'll get to that in just a minute. But this is kind of a growing trend here, the whole idea of a barrier-free bathroom, so I am pretty anxious to show it to all of you here. Welcome, all of you. I see all your names here on the sideline on my screen, so I can see many of you that have signed up, and I recognize quite a few familiar names, so thanks for tuning in for this. I hope you find it informational. So as I said, we just got our AIA accreditation for this and also the IDCEC. So if you're tuning in to get accreditation, I can give you those numbers there. Let's see, for the IDCEC, the number is 106097, and for AIA, it's actually SCHL, like start to spell Schluter, SCHL 11A. So those are the two accreditations, and I know many of you might have other CEUs you can get, and you can self-report those. Now, if you need an actual certificate from us, you can actually contact Paul Lederman at Schluter Systems. You can either call him on the 800 number or just email him, plederman, LEDERMEN, at schluter.com, and request a certificate, and he will email you or mail you a certificate if you need that hard copy or you like to have that. So that is nice to have that ability to gain some credit here on this particular course. Now that we're done there, you won't see anything about Schluter anymore because this is accredited and this is non-proprietary. So what is this all about? Well, we're going to go through the presentation here, and we're going to look at the standards that you'll have to meet for this accessibility. So there's an Architectural Barriers Act. You can see that, the Uniform Federal Accessibility Standards, and the ones that we're going to be using today as far as ADA is the 2010 version of this that's out there floating around. So that's the one. And, of course, we're also using the Tile Council of North America Installation Handbook. They have some guidelines also. So the purpose of this presentation is to really talk about building these type of barrier-free bathrooms. When we say barrier-free, that just does not mean curbless. That means there are no barriers to anyone of any abilities or disabilities that they can use this space. Waterproofing has become a real challenge in these particular curbless or barrier-free showers. There's a lot of custom design elements that like to be incorporated in here, but they also have to adhere to the ADA design standards. Now, that's for public access ADA. You really don't need to adhere to that in residential, but it's always good practice if you're thinking about designing an aging-in-place environment. Aging in place, of course, does refer to ADA and use their guidelines quite a bit. So we're going to have a little bit of both, but you'll see that, but a lot of time I'm going to be referring to the ADA for the standards of design. So as far as this particular presentation, we're going to look and see why is the barrier-free movement occurring, why is it so important, and then again defining what barrier-free means. I think I just did that, and we'll do that again. Waterproofing a barrier-free, that's going to be, again, a bit of a challenge to make this work right the way we need it. It's both design and function, of course. Custom design elements, we'll take a look at those, and we'll look at some ADA resources besides. So why barrier-free? Well, going on right now is a lot of seniors are not planning on leaving their home. They want to stay there as long as possible before they actually have to vacate that. So what they're doing is they're kind of planning ahead. If they've got a remodel coming up, a lot of them are saying, well, why don't we just design for this barrier-free now, even though we don't need it yet, but we could certainly use it sometime in the future. We're planning on staying in the home now. So that's one of the things that's happening. And if you look at the amount of the population in the U.S. that's actually getting to the age where they're retiring, you can see that it's a larger and larger percentage of the population and just a greater amount of people that are going to fit into this category. So this is a tremendous opportunity as far as business opportunity for remodelers and builders and architects and designers and so forth, anyone who would offer these type of services to create these kind of spaces. So you can see this is really a growing concern that we have here. So really, if you think about it, why not just go ahead and do this now when you're doing a remodel? One of the other themes of this particular presentation is it doesn't have to look institutional or unattractive. This can be a beautiful space. You can see from the screen we've got up there that this is actually a barrier-free bathroom. There's several elements that represent that in here. And this actually does have ADA compliance here. It should certainly have all the design and aesthetic value that everyone wants. So we're going to look at a couple of different ones here. We're going to look at roll-in type of showers, which a lot of people automatically go to when they think of barrier-free. And it can be a transfer type. And a transfer type could have a curb, depends on the design, but we're going to stick to even a roll-in there. That'll be a curbless or barrier-free even when we look at the transfers here. So if you look at some of these things, if you've ever explored the idea of actually building a ADA compliant space, you can see that there's a lot of requirements. So just a couple of the highlights here of some very standard designs or that you're looking at here. You can see that this one is 30 inches wide by 60 inches deep, and that's actually inside wall-to-wall. It has a 60-inch wide entry, so one of the long ends is completely open. And then you can see from the dashed line there that you could have a sink in here that would be a basin sink, which would suspend off the wall. And optional is the seating, too. So you could have this as a seating space, too, in this particular bathroom. This would be very hard to actually make this a transfer. Well, it's not that difficult. I'll show you another transfer, but this one would be a little more creative as far as making it a transfer where someone would get out of a wheelchair and onto the seat. You'll see that they would actually have to wheel themselves in facing forward into the slope, and then they would have to transfer over. I can show you some other options here in just a minute. Here's another alternate roll-in where you actually have a fourth wall, but that wall, again, is only a short distance because you need a 36-inch wide entry minimum over the 60-inch and the 36 deep there, and then you can see the optional seat is in there as a dashed line showing you where you would actually have a seat, typically fold-down type of seat that you would put in there. And, of course, we'll get into the grab bar heights and so forth here a little later. Here would be a transfers type shower, and this was interesting to learn this as we went through the process of building this presentation, is that if you're going to have a transfer shower, you can see where the wheelchair occupant is able to get back even with the seat, which means the wall has to extend back behind where the seat is. So that's going to be a 48-inch minimum space for the occupant while they're in the chair, and then you could have as small as a 36 by 36 in the actual shower area. Those could be minimums, but there also could be maximums too because of a reach consideration that you have to keep in mind. So there's a lot of stuff going on in this particular design that you're looking at here. We always recommend that you would actually go in and look at the ADA as far as what you'd need here. So a lot of the ADA that we're looking at here is in the section 608. Starting with point 2 and going through clear up through a lot of point 3. So there's a lot of different deep designs. So if you're taking a note, 608 and 308 is what we're going to refer to a lot in this particular presentation here. So it would be mandatory seating in here if you're going to have a transfer type shower, of course. This is kind of nice where you are limited in space for the actual shower, but maybe you have a little more floor area where you can incorporate more floor area where necessarily you can't say it's dry. We'll get into that in a couple of minutes, but it wouldn't be like in the shower environment totally. So you'll have the ability sometimes to build this or retrofit this into a particular space that you have. So if you really take a look at these, so the difference between traditional and curbless for barrier-free, as I said, you can have a curbless shower that still isn't barrier-free. So, but most barrier-frees are going to be curbless. So that's kind of a way to look at it there. So in a curbed entry, of course, you have a curb which defines the area where the water is going to be contained. And those are built in a couple of different fashions, and we'll look at that here in a couple of slides, how those are put together. But you definitely have an area that defines the traditional wet area from the dry area. But as soon as you take the curb out, whether you're building barrier-free or curbless, either way, you now have kind of blurred that division, that barrier, or that separation where you had a wet area traditionally to what would be considered more of a dry area. So that's something to consider, which is why so many of the surface-applied waterproofings are becoming so popular for this type of application, where you're doing a sealed system instead of the traditional old water in, water out assembly. So when you get these, you really should be looking at this specialized waterproofing method here, i.e. the bonded waterproof membranes, where the tile is bonded directly to the membrane, and then the membrane is bonded over the top of all the different materials you would use to build this assembly, whether it's a design element like a bench or a niche or a shelf, or in this case, you look in the picture, you can see that we've got a recessed floor where we've been able to put a line drain with large format tile. That's all waterproofed, and we've been able to tie that waterproofing out onto the floor, because there's another membrane out on the floor that also has got a waterproof quality. This allows us to tie them together, which is one of the difficulties with the traditional systems, to be able to achieve that. So here's a detail out of the Tile Council of North America Handbook showing how these assemblies go together. We have a stylized drawing showing the water all on the surface going down the drain, and the tile is bonded to the waterproofing that is protecting all the other elements, and that waterproofing is tied right into what's called an integrated bonding flange. Now, that integrated bonding flange is one of the elements that makes the installer, the designer, have the ability to build these with a very low profile. Most times when you have a shower assembly with a drain assembly, all those drains on the market that are manufactured by the plumbing industry are all designed to accommodate the waterproofing underneath the mortar bed. Down at there's a two-stage or a two-piece drain. Those tend to be fairly thick, so you have a lot of recess of the floor area. You have to drop the floor where the shower is going to be substantially in order to accommodate these. This particular assembly here with these integrated bonding flanges and surface drains make for a much thinner type of assembly, and you'll see why that's a benefit here when you get into, let's say, perhaps this type of detail, and we'll look at a couple here in just a minute. So there's the bonded waterproof membrane that bonds right to the integrated bonding flange, and you can see you have a high point, and in this case you do have a depressed concrete where you are able to put the assembly, but I can show you an alternative to that too. So this is sort of recognized on how to do this, but the problem has always been, how do you take that waterproof membrane that's like a pan liner, if it's under that mortar, and tie it to the waterproofing you should have out on the high point on the floor and make that a watertight connection between those two? That's always been a troublesome spot and a challenge, and actually there's no detail showing how to do that. So we're really left with not a lot of direction with the traditional pan liner such as this in order to tie in to other waterproofings outside the shower. And now that we've removed the curb, those areas should really be considered part of the wet area too. That could be someone who would wheel in and shower and then wheel back out to dry out. That area is going to receive a lot of water. It could be where somebody needs assistance for their bathing, which you would need a lot more space, and you'd have to utilize outside space. And so really we should be considering outside what was the traditional wet area to be part of the wet area now. So it's going to be hard to tie these together. So here's another one. This is where you see the continuous membrane, and this is required. And you can see the Tile Council of North America detail number there. This is from the 15 handbook when it first showed up in that book. Of course, this year's would say it would say 422C-17, and if you have a current book 16, I know the new 17 book isn't out by the Tile Council yet. They typically get those out to coincide with the covering show, so we should be looking for the 17 version shortly, but you'll find this in all the TCNA versions since 15. Another nice aspect about this is you can see that this particular assembly was built on top of existing substrate where you wouldn't necessarily have to recess the floor, which could be quite costly and time-consuming if it's concrete or wood. This gives you the ability to build an ADA-approved shower, if you have the square footage, really, right on top of the existing substrate. So that's a really nice opportunity to put one of these in without major renovation, if you will, or modification to the substrate before being able to put one of these assemblies in. But nonetheless, you can see how this is going to tie together from the wet area right into what's considered the dry area, which really could receive extensive water. So here's how you tie these surface waterproofings together right on the surface, and then both of these materials are ready to accept the tile. Also, you can see here's a job in progress. They've got a portion of the tile up on the walls, but you can see that you should go up at least above the shower head when you extend the waterproofing. That's one of the designs. That also is a fundamentally different between this and the pan liner that I showed you earlier, where the pan liner only extends up about 3 inches above finished height. This one will extend all the way up and provide you even an extra level of waterproofing on all the substrates in here. As you can see here in this picture, it happens to be not only in the pan, but actually on the walls too, and we'll continue that. So there you go, curbless or barrier-free, again, B422C. You can see that the C there stands for the curbless, and you can see how you can tie in if you have a surface waterproofing and an integrated bonding flange in these assemblies. Now, another element that's become quite popular are these line drains, linear drains. The nice thing about those are you can use any size tile. So many cases people want to use a large format tile on their bathroom, and they don't want to necessarily switch to a smaller format as they go into the shower now that there's no curb and door. So this gives them the ability to stay with the same large format tile that they had on the bathroom floor and just continue that right into the shower area. So that's kind of a nice design element to, if the tile is suitable for that particular environment, you could certainly use it right into this wet area here. So that's a nice thing about the large format. Another nice thing about these type of assemblies, when you go to the sealed systems and the waterproofing is up on top, in many cases you can move the drain to the front of the shower instead of the back. So it now intercepts the water as it's coming from the back wall towards the front. The benefit of this, if you think about it for a minute, the whole floor in the bathroom is now at the lowest elevation of the area of the shower instead of having to be the highest. So this gives you the ability to have a minimum barrier as you go into the bathroom space itself. You don't have to have that huge elevation change, nor do you have to have the drop in the space that's going to receive the shower assembly. You don't need that recess there because you can build it in this fashion. So this has become quite popular because of the ability to retrofit this and get the slope, use large format tile, and have the shower have the highest area, say, and you see the person applying the membrane behind his feet. Behind him is the high point in the entire bathroom. So now you don't have that big elevation buildup or the need to recess the floor at all, or certainly not at a drastic amount. If you do these type of things, and you've done these in the past, and you find some water flowing out onto the floor, in many commercial applications, there's a requirement to have a secondary drain outside on the floor if you're going to do this. But this is another alternative. You can see this is a retrofit profile that will actually keep the water from flowing out onto the floor. This one that you can see from the small inset picture can be put on top of existing tile. If it's something you plan in, then you can see it can be less obtrusive. This one actually has a profile that sits into the tile and then an insert over the top that will prevent the water from flowing any further. So that's another nice design element there, very low profile lip. Now when you get into lips, into these access areas, there are some pretty strict designs and details here. You can see from the beveled stylized drawing below the roll-in, if there's a maximum change in level of a half or less, you can see that there's got to be some bevels in there and a maximum amount of straight, upright, 90-degree angle to the floor of 1/4 of an inch. So these are things you have to keep in consideration. Now, if you have a transfer type, you can have a 1/2 inch, and that can be rounded, beveled, and you can actually have that vertical in that particular case, up to a maximum of a 1/2 inch if it's a transfer. But if it's a roll-in, nothing over 1/4 of an inch, maximum straight up vertical before you would actually have to put a bevel, or we'll take a look at some slope ratios here in a minute. Here's where you'd actually enter the space from an adjacent floor and come right into the tile area. And this is nice because you haven't had to have a huge transition between existing living space and the rest of the home and into the bathroom area, which is, again, as far as design and planning this thing, is going to make it easy to have an ADA-approved slope ratio profile that can come from the adjacent flooring up onto the tile covering. Here's another one that gives you even a more smooth transition. This one comes in 2 inches or up to 3 inches wide as far as the ramp itself. This gives you a very nice and easy transmission, not abrupt at all, so you can roll someone in there without jarring them too much as you go in. And these, again, are ADA slope ratio because we never make one that's taller than the maximum that you could have there. So when you look at this change in level, you can see it's a 1/2 inch. That's what you get. And but if you are going to go more than a 1/2 inch, you can see that the slope ratio changes from 1:2 to 1:12. So that becomes a substantial wide ramp if you go more than a 1/2 inch in height from one to the other. And you can see the maximum rise or length of that ramp is 30 inches. So there's some good design elements to keep in mind when you're looking at that particular thing. And you'll find that in ADA 308. This one's quite popular when you get to some of these types. So here you go. Ramp tolerances in existing buildings. There is a little bit of leniency in an existing building as opposed to new construction. They do give you a little bit of a leniency. You can see it can be a 1:10 to 1:8 slope if it's a 3-inch rise, and you can go 1:12 to 1:10 slope ratio if it's going to be 6 inches rise. But that would be, again, retrofitting an existing building. So a little lenience there, but typically if you've ever tried to navigate one of those on your own in a wheelchair, that's tenuous at best. I'd want an assistant in there. So you can see in this particular case here, we have plenty of maneuverability area in here. This is a 6-foot square tray that's set on top of the existing substrate, and then an ADA slope ratio ramp that fits in front of it. And then we have a bench over to the right, and we'll get into that, into the actual dimensions of that here in just a minute. As far as the reach, that also is part of barrier-free. So it's not just taking the curb out and putting a ramp in front. There's a lot of other considerations when you do these. You can see as far as unobstructed forward reach, there is a certain dimension where it would be a maximum height to a minimum height there, and also in the side reach. And if you have an obstruction, some sort of shelf or sink or something like that, there's going to be different maximum and minimum on there also. For instance, if it's an unobstructed, the forward reach, you can see nothing can be put above 48 inches off the floor or lower than 15. If you have an obstructed high, that's going to be 48 with a 20-inch maximum depth of a bench or shelf or sink. But if you go to something that's up to 25, then it has to be a little bit lower in order for an occupant of a chair to be able to reach that high. So that's 44 inches off the floor that you would have there. Side reach here in a barrier-free. Unobstructed, you can have something up to 10 inches wide coming off the wall, up from the floor, where you have a side reach there. But then again, your side reach is a 15-inch minimum to a 48-inch maximum. If you have an obstructed high, you see that there's actually sort of a shelf or wall that's been put into this environment. Again, 10 inches wide, and it can be up to 34 inches high, but then your reach again is 48 inches there from whatever the height of your wall would be, your shelf there. In this case, is 34 inches. So it's going from 34 to 48 is actually your reach area. If you're going to make it deeper than that, you can see if it's anywhere over 10, up to 24 inches wide, and up to 34 high, then it can't be above 46. So really strict guidelines on these to give the occupant the ability to really use the space. So when you think of barrier-free, it's free of any type of barriers that would inhibit someone from using this type of space. Now, children have a different particular type of thing, and you can see they actually get into their age groups based on about what size they would be when they're in those age groups. You can see here for forward or side reach, there's a high and low, max and min for those as far as what they can. And then, of course, we get into the adult, which we've looked at there already. Another thing to take into consideration is a vanity. You certainly couldn't build a barrier-free shower or bathroom, I should say, and put a standard cabinet like we see in so much residential work in there. So there's the ability to actually use the sink and then actually get to the controls also. So all these things need to be taken into consideration. That's why this is so popular, to actually go to, say, a cantilevered vanity where someone who occupies a wheelchair will able to get up to the sink and use it and have ability to reach any of the controls or anything based on the reaches that we looked at in an earlier slide. Niches and shelving, again, these are design elements that not only are nice as far as their looks, but do actually meet the requirements. If you build them properly, if you design them and get the dimensions properly, you can incorporate these in here. So this kind of goes back. You look at that cantilevered sink and how beautiful that was in the previous slide. And then you look at the slide here where you can see these aren't done yet, but you can see that they could be very nice design elements. When people are building these things, like I said earlier, they're not necessarily ready to use these things. They still have other abilities, physical abilities, but they're designing and planning ahead. This would all be something that would go into a design element that is not considering barrier-free or ADA at all. This is pretty standard elements of design that you see in this current bathroom trend that we're looking at now. So you can get both the design and the function. What you've seen a lot of these things being built out of, pretty prevalent on the market these days, is foam core building panels. They come in various thicknesses depending on what you're doing with them. They're very lightweight. They won't warp. They won't rot. A lot of time you can eliminate, most of the time you can eliminate any other type of building elements in there, such as any kind of wood, plywood, OSB, dimensional lumber or something like that. You can get that completely out of that area. And, of course, the benefit of that is that this stuff is much more stable and won't warp or rot, where the wood, of course, would if you wouldn't protect it completely. So prefabricated shower niches are readily available. Many manufacturers make these in various configurations. So these are something that makes it very simple to add this design element into here. Just bear in mind the reaches and the dimensions, how far up off the floor, and if there's an obstructed or not obstructed element below it. Keep that into place. Again, steam rooms, people like the steam room. Here you can see there's a partition wall or pony wall built out of the foam core elements, and then a bench that's built out of the foam core element. And since you could see that someone could align themselves up to the side of the bench, the end of the bench that's right in front of our picture here, that this would actually qualify for transfer type, if we put the grab bar in the right place. So as far as the ADA standard dimensions, boy, you really have to follow these. You can see here there's a minimum and maximum depth and height up off the floor, how deep the bench is, how high the wall can go, and if you look at the little inset, if you're just going to build something or introduce something that's a little more institutional or utilitarian, the inset tells you the minimums and maximums and how much space you can have up off the bench before you actually get to the backrest there. So there's a lot of guidelines that you would have to follow here. But, a lot of people might opt for that, but if you look at the one that's in the big picture, once that's tiled, it's going to be quite beautiful and very attractive. And no one would really consider that to be an element that they would automatically identify as, oh, that's a barrier-free shower. That doesn't necessarily be the case. In this shower, if you look closely at the picture, at the very bottom at the front of the bench, you can see that the line drain is placed at the front of this particular shower environment there. So resources that were used here, we did use the ADA 2010 that gets you all the compliance standards. You can see the 300 to 600 series. We looked at the ramps. They would be available in your 400 series. The reach, again, is in the 300. The seating would be either in the 600 category or the 903. So you could look this all up at ada.gov. That would be your reference if you don't have one of these now. I strongly recommend that if you're building a total barrier-free that's going to comply with ADA, that you do get access to one of these things, because there's a lot of guidelines, as you saw as we went through just a few slides on how this goes together. And the detail we looked at in the Tile Council of North America Installation Handbook, again, was B421C and B422C. So those have been in the book since 15, so that's something to take into consideration. So key takeaways, there were a lot of elements here that gave us the ability to build one of these things and have trouble-free service. So it had the design element, and it had the functions that we're all looking for, such as custom building panels, which allows us to build these design elements, line drains, which makes for easy access, one plane sloping towards the drain, back placement, intermediate placement, front placement, and of course the ability to use large format tile. Other prefabricated components, which again makes it very simple to build one of these. Also to give you the ability to design and build one of these on top of existing substrates. And then we looked at some profile trims that gave us the transitions and water dams and so forth that we also needed here. So as far as the barrier-free, you should really be looking for a sealed system, a surface waterproofing where the tile bonds directly to the membranes, because you can see from the checklist, the chart here, that's going to be the easiest to integrate a lot of the design elements. You also can integrate between what was traditionally wet to traditionally dry, and yes, you can just run those right together. They are suitable for barrier-free, but when you look at the traditional pan liners that have been utilized for a few decades now, it's going to be really, really difficult to try to tie that thing in and make a watertight seal between the shower environment and out onto the floor and onto other type of design elements like benches and niches and shelves and so forth. So that's a real, gives you a real good indication of the direction you should be going on this particular assembly. There was a lot there, I do know that. Jim, you did mention earlier that this is going to be saved in the archives and people will be able to access.
Absolutely. I did put my email address in the chat screen, so I noticed I've got about 25 requests already for the archive version, and I'll send that later today.
Okay, great.
What a great presentation, Andy. Lots of new information, lots of good information. I do have some questions for you, if you have a moment.
Okay, I'm not ADA qualified, but I'll try my best.
I love it. I love it. So I think on slide number 29 or around in there, it said something about water running down. What about water that runs down the ramp? was a question, and I'm not sure I understand the question completely. So.
Sure. Well, I think what they're referring to there is where we could put a ramp in front of the other, say, a shower tray, a prefabricated tray. Now, when you look at the minimum maneuverable area that you have to have when you build that type of shower, it's minimum 48 inches square. So you're going to rely on the size of the shower floor, the actual square footage of the floor, and the placement of the either handheld wand or the permanent fixed shower head, that you're going to have a lot of the water remain in there. Yes, some water can and will get down the ramp, so that's where a secondary drain may come into play that you could put in the floor, or you would actually put one of those little barriers that I showed you, one of those little dams right at the top of the ramp, and keep the water from ever getting there. There's no doubt some water is going to get out onto the floor. That's why also in that design element, and I failed to underscore this when we were looking at that and show all and point to this to all you folks that were watching it, but there's a requirement that the waterproofing, if you're building a curbless, barrier-free shower like these, that the waterproofing extend a minimum of 12 inches out past the high point. Now, we would recommend that you would actually extend that waterproofing out considerably farther than that, and if you're using an underlayment that's waterproof in itself, a tile underlayment, like we saw in many of those photographs, that you actually treat the seams of those and really run that out considerably farther out past that shower. So that is a design element there. I do appreciate the question. I hope I answered it.
Great. How are you achieving the 2-inch required distance from the top of the drain to the top of the threshold that is required per some plumbing codes, 408.5?
Yeah, that plumbing code has been bouncing around for a number of years. It still seems to be active in some places, but what you'll find, that code actually is actually referring to a flood test. So we have, in many instances with the company I work for, we've had to put in a temporary curb to just execute the flood test to get that 2 inches of water that they want over the top of the drain. That, again, is another consideration as far as the size of the shower. In many cases, that is an old detail, and when you build barrier-free, they actually have some new details where you would not necessarily have to comply to that. I would say what was important is that we as a company, the company I work for, have plenty of people out in the field that could actually discuss that with the plumbing code compliance officer, because in many cases when we look at a barrier-free or an ADA, the compliance can change a little bit, and there's some leniency there. Because if you imagine that, if you have to have 2 inches from the drain elevation to the high point of the shower, and you can only have a 2% slope, which is basically 1/4 inch per foot, that means the high point in your shower has to be 8 feet away from the drain itself. Well, that makes for a really big shower. And in many cases, you just don't have the ability to do that. So it was an unreasonable requirement back in the day. I kind of see why it was there back then. But, again, and I tell you, this is also troublesome. I travel around the country, both in the U.S. and Canada, and I find that particular code is sometimes not even adopted or has been abandoned. Sometimes it's still there. It's really up to the interpretation of the building inspector on site. And we've actually had to go to the head building inspector of the city or county or state or whoever it is and give them some other details to say, we can see where that was important once, but now that's just not going to be, it's not possible. You're just not going to be possible to have the ADA slope ratio that's required to have 2 inches of elevation between high point to low point when you don't have 96 inches from high point to drain. So that's a good question. It is really kind of a sticky spot out there in many cases. We deal with that on a case-by-case basis, and I can tell you we've had quite a bit of success.
So someone mentioned the old plumbing code can be addressed by measuring to the bottom of the linear drain, just as a comment.
Yeah. Yeah, that could kind of help you out a bit, too. If you can squeeze that extra, those linear drains vary, but they're typically I could probably throw a number out there and say generally about 3/4 of an inch deep. So that gains you right there 3 feet.
All right.
Or
And
allows you to minimize 3 feet.
And then I think on about slide number 46, someone asked about the use of Red Guard for waterproofing, and wanted to know if that will work.
That is a surface waterproofing, certainly.
Right.
That is one of the ones that's on the market. 46, huh? Let's get that to there.
Somewhere in that range, like 45 or 40.
Okay, somewhere right around there. I don't think it was that slide, but yeah, certainly. There's sheet-applied membranes, which you saw in this particular presentation. There are trowel-applied membranes that you put on with a particular notch trowel prescribed by the manufacturer, and then you flatten them out. That gets you the thickness required. There's other liquid-applied or roller-applied where you actually put them on, kind of paint on, and then you paint on a number of coatings to get to the minimum required thickness from that manufacturer. So all those are viable ways to achieve surface waterproofing, certainly.
You mentioned the possible need for a second drain in a room when placing barrier-free showers. Are there requirements for this? And is it only when the drain is at the door to the shower, or is this a regional requirement for all barrier-free showers?
Well, again, great question. It does actually differ depending on what state and even down to some cities. But typically, I would say just generally we could make a general statement and say if it's a public access area and you do not have a curb, regardless of where the drain is, they're going to require another drain, an ancillary drain in the floor outside. And it actually will be at some proximity to the end of the shower environment, if you will, say 12 inches or so. It just depends. But, yeah, it really doesn't matter where the drain placement is. If you're doing commercial work or public access work, they will almost always require that. It's more of a health code requirement than something from the, say, the plumbing engineer or the mechanical inspector.
All right. And do you recommend some sort of water containment for a residential application?
Yeah, everything should have a water containment. There's no doubt about that. We want to try to manage the water, get most of it down the drain. The reality is if you are building ADA barrier-free, that there's going to be some water that's going to get out onto the floor, whether it's the occupant themselves removing themselves from the shower environment, or if they have an assistant. When you take the curb and door away and you have water splashing around in there, there's going to get some water out. So it's always a good idea to have water containment of some sort, whether you put that at the subsurface and try to tie into a surface waterproofing on the floor, or if you opt for what we showed here, which was a sealed system where the waterproofing is on top of the surface everywhere, not only out on the bathroom floor, but right into the shower environment. Yeah, you're going to want to contain the water as much as possible. Many of them, you saw the slope ratios for the ramps. I see many of them made where they're recessed into the floor, and you have a little bit of a ramp, and you saw the slope ratio. If it's a half inch or lower, the ratio is 1 to 2. If it goes above a half inch, then the ratio is 1 to 12. So really it's up to the designer to design how wide the ramp is, how much drop it has. But in many cases, the showers that I built in my career as a tile contractor did contain a half-inch elevation change that I did at the front of the shower as it dropped in, and then I would put the drain at the back wall. And back then, boy, line drains were rare if you could ever find one. So it was typically a centralized drain. And when you go to a centralized drain and you're putting it at the back wall, again, you better refer to the ADA because there's a maximum and minimum away from the wall that can be if you're going to actually slope to that point there.
When do we install a drain? When we install a drain at a door, do we not have to slope upward on the outside of the drain as well?
Not necessarily. Oh, I'm sorry, Jim. Was there more?
Go ahead. No, that's it. Go ahead. Sorry.
Oh, yeah. That not necessarily. It just if you put the drain in properly and you put one of those little ramps or bumps, speed bumps, if you will, right outside the shower, you don't have to have any elevation up to the existing floor. But what they mentioned is another option. You could have a little bit of a slope down, and it doesn't take much to retain the water on the slope, on the downslope from one of those if you're going to put the drain at the front. So if you wanted to build in just, say, 1/4 of an inch of elevation change as you came up out of the shower right at the line drain, if the line drain's at the front, you could do that. We've seen several of those built with components from the company I work for, and that's another option. Then you don't have to put that little speed bump at the front.
Great. What are your thoughts on the folding chair type of mount that goes to the wall versus the built-in seats?
Well, I think it's just really a design, an aesthetic call on part of the consumer. Sometimes it's a space consideration. If you think about it, so many people want benches in their showers now, just as a design element. It's become pretty standard for designers and builders and installers to put benches and niches and that type of thing in bathrooms now. So if you do want to build a permanent bench, then I would build it. And mostly if there's plans to stay in the home, aging in place type of situation, I would build it to ADA standards so they wouldn't have to tear it out later. But if you want a fold-down bench because you just don't have that big of an area, you're like a couple of those designs we looked at early on in the presentation had pretty small footprints. So if there's other occupants that don't need a transfer bench, then maybe the fold-up one does make sense because you can kind of fold it up, get it out of the way, and then anybody could use that particular bathroom and not have the obstruction of the bench because they do fold up and down against the wall.
Great. Are all of the trowelable and liquid waterproof membranes okay to use in steam showers?
Well, yes and no. The quick answer would be no. You better check with the membrane manufacturer on limitations of that. Some of them just absolutely say, no, we're not good for steam. We don't meet the new requirement that was just brought out by the Tile Council of North America just a couple of years ago. They're just not going to meet that new stringent requirement as far as what's called a perm rating. It's basically measuring how much heat and moisture in a vapor form can pass through the membrane over a given amount of time at a given temperature and humidity level. Some of the other ones that are on the market that are liquid applied will comply, but they will also require, some of them, a different mill thickness, in other words, a buildup thickness. So you just have to really look at the manufacturer's requirements and performances and see which ones will, which ones won't, which ones can be modified by extra thickness or something like that in order to comply.
Great. And our last question, it's a little bit off of the shower side of it, but are you aware of any standard details for water containment around a floor-mounted toilet flange?
Oh boy, is that a loaded question. That's a great question. Thanks, Davis. Yeah, no, really, it's a great question. If you look at the health code, you are required to seal the toilet to a hard surface on the floor. But also what's important is that the toilet be sealed to the ring, to the actual plumbing flange adequately, and that won't leak. But if any water is out on the floor and gets in there, yeah, you want to seal that up. But then you find some codes in some states and counties I've seen where you seal the toilet to the floor, but you don't do it in a couple of inches right at the very back of the stool where it would be basically facing the back wall where no one could see it. And that would be making allowances for if something's leaking at the wax bowl ring, that the water would not dwell in the assembly but could get out onto the floor. The homeowner or building owner could observe that there's a problem and fix the leak more readily. I just don't really agree with that logic. If you're sealed up tight under there to the with say the wax bowl ring of the stool to the flange, and you seal on top of that to keep any water from getting in, I think that would be a better bet. But yeah, that's all over the place. I wish there was a standard. I wish we could really agree on a standard nationwide. But all states are autonomous when it comes to what part of codes that they adopt. There's international residential code, there's international builders code, there's national, there's like I said, some states have adopted some UPC, Uniform Plumbing Codes, and not others. It's really kind of confusing as you work around the United States, as I do. And I found that the people who stick to one jurisdiction have a lot better go of it because they know what the standards are, what the expectations are there where they're actually practicing their business.
Well, Andy, great job. I want to thank all of you that attended today. Please look forward to our next webinar coming up shortly, and we'll be in touch with invites. Thank you very much.